One of the first things we learned to do was design proteins that bind to other proteins, for example, to viral proteins and block them. The next thing which we tried to do was design proteins which could have multiple states, which could switch between those states. And the third thing that problem we worked on is, or have worked on, is, as I mentioned, proteins that can break chemical bonds. So a basic machine has to take some kind of fuel, and that fuel should power some cyclical process where it can sort of change the surrounding environment. And so by combining those three capabilities, binding, conformational change, and catalysis, we can actually start making machines. Now, some of the problems we're interested in making machines for are in medicine. For example, inside our cells, there's very elaborate quality control machinery. So if anything goes wrong, it gets fixed quickly. And that's how cells like bacterial cells can keep dividing. Cells in our bodies are in good shape. But the problem is outside of our cells, there really isn't any system like that, which uses energy to sort of fix things that are broken. And so one of the things that we're very interested in now is designing nanomachines that can circulate and and clean up stuff that shouldn't be there, repair broken tissue, and so forth. And because we can design these sort of new catalytic sites, we can use fuel molecules that nature never thought of. For example, it could be something that's in your diet. There could be some type of food or food additive that actually, when you eat it, it goes into your circulation through your body, and that's what happens when you eat triglycerides and sugar and things. They sort of go into circulation. And this now becomes the fuel to power those machines. Other examples are machines that could, for example, help untangle the amyloid fibrils that have been associated with neurodegenerative disease. Outside of medicine, there are a huge number of possibilities. You can imagine machines that help pattern atoms in specific ways, so allow fabrication of materials in a bottom-up approach. So there's really a huge number of possibilities.